How's it going? All right. So the exam, I'm going to have grades for those tomorrow.
Okay.
And they'll be sent out through email. But today I want to go over the exam. And yeah, it looks like we have somebody in the stream. So, number 1 says determine whether the statement describes a population or a sample. And so the example it gives is the amount of money each person in your chemistry class spends eating out each week. Okay, so is that a population or a sample? Yeah, easily a population. We're talking about the entire chemistry class, not just a specific section of it. Okay? 2, If the researchers administering care know which partakers have been placed in the experimental or control group, but the partaker does not have this information, the experiment is which one? Single blind or double blind? Not double blind, it's single blind.
Oh, yeah, single blind, I'm sorry.
Okay. Yeah, so in this case, the researchers know what group each participant's in, so it's only single blind.
Yeah, the one on review.
Yeah. Okay. This one ends up being a little bit weird. Determine whether an observational or experimental study is appropriate to address the following statement. So a car wash operator wants to find out if a need for additional staffing exists. So what do you use, observational or experimental?
Observation.
Okay, so that's what pretty much everybody's saying, which is good. Everybody's got a consistent view on this, but I would say that you could feasibly make an argument for experimental as well. So I'm actually going to make this one a free question. So no matter which one you answer, you get it right. Because yeah, you could observe the data that maybe you've collected over the past few months and determine what your productivity level is like, but also you could just hire another employee and then observe your data. So is there a change? So yeah, I'd say you could do either observational or experimental. Okay, 4. A college administrator wants to know if the SAT scores of incoming freshmen have an effect on their end-of-year freshman GPA. The SAT scores would be considered the what? Response variable or explanatory variable?
I put explanatory since SAT would explain.
Very good, yeah. Perfect, yeah, it's the explanatory variable. So in this case, the SAT score would explain, like you're saying, the increase or decrease in freshman GPA. Okay, and so the response variable here would be that GPA. It's responding to the value of the SAT score. So if the SAT score is higher, we can probably expect that that will mean a response in a higher GPA for the end of year freshman grades. Very good. Is there any questions about any of these? No? All right, good. Next, a mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. Okay, so what percent of the complaints are due to the category extra data usage charges? Round your answer to 2 decimal places if necessary. Okay. So extra data usage charges is right there. It's the one that we want to focus on. And we want to compare this to the rest of the data as a percent. So we need to know what else besides just 87.
Total.
Yeah, so we need to know the total. So we're going to take each of these frequencies, add them. So 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156 is 790. Okay, so again, this needs to be a fraction. It needs to be a part out of a whole, right? So is this going to be 87 out of 790 or 790 out of 87? In other words, if we make this a fraction, is 87 going to be on top or bottom? Yeah, good. I'm only asking that because there were a few people who got that backwards. And that was the one mistake that I saw on this question, is just getting that fraction backwards. But from this point, to get our percent, what would we do?
Divide.
Yeah, just divide that. 87 divided by 790, and then multiply by 100 to convert it into a percent, since this would just give us a decimal. And round it, and we get 11.01. Awesome.
No, I got 9.08.
Oh, you did?
Yes, sir. So I don't remember exactly what it was wrong, but
But you did 87 divided by 790, right?
I believe so, I think I did it the other way around,
Ah, okay.
I think so.
Well, let's just to see, what would that come out to be? 790 divided by 87. Yeah, it would. It'd be 9.80. I'm sorry, 9.08.
Yes, sir.
All right. Again, that's why I was asking, which way would it be? All right. Next. Well, does it make sense why we're doing it that way?
Yes, sir.
Yeah,
Yes,
okay.
sir. Yeah, I understand that.
So next. And it wants us to find the mean, median, and mode for this set. Well, what's the first thing that we should probably do with this data?
Put it in order.
Yeah, absolutely. So, negative 14, and then negative 13, negative 8, negative 7, negative 5, and 5. Excuse me?
Oh. I think I put negative 7.5 when I was doing that.
Oh, yeah, it kind of does look like 7.5, doesn't it?
Yes, sir, I may not have the,
Well, if that's what it is, and you put 7.5 instead, then I'll recalculate it and see what your answers are, and if they're correct for this being 7.5, then I'll give you points for it.
yes, sir. Yeah, I got negative 9.5 for this one, so, let's see.
Okay. Yeah, so if we get the mean for this one, let's see, that'd be negative 14 plus negative 13 plus negative 8 plus negative 7 plus negative 5 plus 5. So negative 42 for the sum, then divide by 6 for the number of data points we have, and that comes up to negative 7.
Yeah, I knew it was 7.5.
Okay. So now we need to find the median. So that's the middle number.
8.5.
Ooh.
No, I put down negative 8.
Okay,
So
so
that's also because I thought there was 5 numbers there.
yeah, there's 6 of them.
Right.
So it'd be, count in, we have 2 numbers in the middle. So between negative 8 and negative 7 is negative 7.5.
Okay.
And remember, if you ever have any doubt, you can just do like, negative 8 plus negative 7,
Right.
then divide by 2. Yeah, negative 7.5.
Yeah, this whole section is messed up for me.
Okay. Well, you probably got the third part right.
Yeah, no.
Yeah. So there's no number that is repeating here, so there's no mode. All right. So, any questions on this one?
No, sir.
No? All right. And again, I'll give you some points back for this one, since it's just that one thing that threw you off. All right. Next one. Calculate the GPA of a student with the following grades. So C for a 16-hour course, B for a 5-hour course, D for a 12-hour course, and then round to 2 decimal places. So the first thing we need to do, of course, is convert these letter grades into actual numbers. So C is a 2.0, B is a 3.0, and D is a 1.0. So now do you remember what we need to do between these grades and the hours?
Was it multiply?
Multiply them, yeah. So 2 times 16 is 32. 3 times 5 is 15. And 1 times 12 is 12. And then what do we need to do with these numbers now?
We add them together?
Exactly, yeah. We get the total value that we achieved with these grades. And they need to be divided by, do you remember?
Is it not average, you say?
Yes. 16 plus 5 plus 12. Perfect. All right. So if we add these numbers, 32 plus 15 plus 12, get 59. over, let's see, 16 plus 5 plus 12 is 33. So now we divide them. 59 divided by 33, and then round it, we get 1.79. Good. Any questions on that one? All right. So next one, we've got a graph. It says, for the graph shown, determine which letter represents the mean, the median, and the mode. And letters can be used more than once. So this is a frequency distribution. Okay, so as this increases, we have a number that is more and more frequent. So these numbers over here aren't very frequent. These numbers over here are very frequent. In other words, they occur a lot. So that would mean that B is which one? Yeah. Okay, so now median is which one? Yep. And A is the mean. Good. Very good. I'm guessing you don't have any questions on that one. All right. We're flying through this. Yeah. Okay. The next one gives us some data and wants us to calculate the sample standard deviation and the range. So sample standard deviation is x equals the square root of the sum of x minus x bar squared over, and this one's sample, so what's it going to be over? N minus 1, yeah. Okay. So we need to know our x bar and our n. So x bar is the sample mean, and n is, of course, just the number of data points we have. So what is our n? Yeah, 6. So let's add these up and then divide by 6. So we have -5 plus -15 plus 3 plus 3 plus -5 plus -5. So that's -24. Divide by -6. I'm sorry, +6. We get -4. Oh, shoot. Wrong place. I've been so close to doing that every single period. And I finally do it the last one. Okay, so now we can go ahead and work on our formula. Of course, the first thing we need to do is x minus x bar. So take each of these and subtract our mean. And remember that we're subtracting the mean. So we have minus -4. Well, what's minus -4 really mean? What do those double negatives make? Positive. So yeah, we're actually going to be adding 4 to each of these. Okay, so -5 plus 4. Then, okay. Good. Yeah. Perfect. Good. All right, now we need to square them. So -1 squared. -11? Not 22. It's 11 times 11.
Oh, yeah.
So 121. Is what?
42, right?
49.
49.
Yeah, it's 6 times 7 is 42. So
Okay.
pretty close. 1 and 1. All right. So we've got them squared. Now we need to add them. So 1 plus 121 plus 49 plus 49 plus 1 plus 1 should give us, yeah, 222. And then we divide by n minus 1. So divide that by 5, we get 44.4. Now, do you remember what this value is now? We haven't taken our square root. Once we take our square root, we have standard deviation, but before that, we have what? Do you remember? Okay, it's called variance. Variance? We didn't go over it in this class because it's not very useful to us with what we're doing. But variance is basically a measure of how much these numbers vary between each other. So how spread out are they, you know? But yeah, before we take that square root, it's variance. Once we go ahead and take the square root, then we have standard deviation. So 44.4, take the square root, and we get 6.7.
Yeah, I messed up pretty bad on that one, so I don't know what I was thinking, I just took one of those numbers and just stuck it in the X for the result.
Okay, that's a pretty classic mistake.
Yeah.
Yeah. So, in statistics, X means a different thing from when we're talking about it in algebra.
Right.
So X is all of our X values.
Okay.
So for each of these, we need to do an X minus X bar. Of course, yeah, if it was algebra, then we would just be taking a single number, plug it in there. I think what might help you in the future to remember is that this big sigma means that we need to have a sum.
Oh.
So we need to have multiple numbers to add together here. So that might help you in the future. And then the range. So we need our smallest number and our biggest number. What's our smallest number?
Maybe 15.
And our biggest number? So range is the biggest number minus the smallest number. So again, what happens with a double negative? Positive, so 3 plus 15?
18.
Good. There's our range. All right. Any other questions on this one? All right.
I didn't even answer the last one. So.
Really?
That's it.
Just too intimidating?
Yeah, I've been through it multiple times.
Okay. Well, I'll go pretty slow with it then. So most of this top part is useless. It's just setting up the background. So suppose a company wishes to predict sales volume based on the amount of advertising expenditures. Sales manager thinks that the sales volume and advertising expenditures are modeled according to the following linear equation. Okay. Now, the important part is both sales volume and advertising expenditures are in thousands of dollars, because that tells us how we need to plug in our number. Okay? This part is the most important part here. So, estimated sales volume equals 49.48 plus 0.51 times advertising expenditures. The big thing is you need to know where to plug this one into. So if the company has a target sales volume of $225,000, how much should the sales manager allocate for advertising in the budget? In other words, solve for advertising expenditures. So again, sales volume is going to be $225,000. We're going to plug that into here. But remember that it said that this is in thousands of dollars. Right now, this is a normal number. We need to convert it to thousands. So to do that, we divide it by 1,000, or in other words, take the decimal and move it 3 places to the left, and that will give us a number in thousands of dollars. So 225. So we take that, plug it in for estimated sales volume. Make sense so far? Okay. And then we just write the rest of this equation. And I'm going to call advertising expenditures A. Okay? Yeah, that's what we're trying to get by itself. Okay, so now, do you know what we would do to start getting A by itself? We need to eliminate numbers on this side. We can't add this and this, because this is just a number by itself. This one is trying to multiply by something.
Okay.
In other words, we would say that these are not like terms. You can think of this as being 0.51x. So this one is a normal number, this one is an x number. So we can divide 0.51, but we'd have to divide everything by that. And it's gonna be kind of a hassle to divide 49.48 by 0.51. I mean, I definitely need a calculator for that one. However, if we subtract 49.48, again, because this is not a like term, we can't subtract it from that, and so we don't need to subtract it from that, because this isn't a like term with this. So all that happens when we do that is this cancels, and of course we need to do the same thing to this side. So subtracting something is pretty much always going to be the choice when you're solving. The first thing to do, anyway. Okay, so now we need to figure out what we get there from 225 minus 49.48, and we get 175.52, and now we just bring down everything else. So this canceled, we don't need to bring it down. This is what we need to bring down. Okay, so now that there's only one thing over here, if we divide by 0.51, it's the only thing that gets divided by it. You know, there's no other numbers around on this side that get divided by it as well, so it makes it a lot easier. Of course, we need to do the same thing to this side. Okay, so 175.52 divided by 0.15, I'm sorry, 51, is 344.157, I'll round it for you, equals A. Okay, now this is very close to being our answer, but remember that we converted our original number into thousands. We got to convert it back into a regular number now. Okay, so just like we took the decimal and moved it 3 places to the left, to convert it back, we move it 3 places to the right. So move this decimal 1, 2, 3 times. We have 344,157. So does that make sense? Okay. Do you think you could do that in the future? All right, because we are going to be doing some of this kind of stuff in the future, is plugging those things in and solving. Oh yeah, this is all algebra.
Yeah, the only thing I messed up on, I would have made, I guess I would have made it 80, but I messed up with the 7.5 instead of 7.
Yeah, and again, I'll give you some points back for it, because you know you did the right thing, you just had the wrong number.
You go back and solve it, I'm sure I got
Yeah,
that right.
yeah, I'm sure you could do it in any other setting. All right, any other questions? All right, well, I don't see any reason for us to continue. That's going to be it for the day. Wednesday, of course, I'll pick up where Miss Lamar leaves off on her lecture.
I have a testimony tomorrow, Thursday.
In her class? All right. Okay. Well, I will see you, Bill, Doughton. I know everybody by their last name.
I'm used to being called Bill, so it's okay.
All right. Have a good one.
You too.